Hello students, last time I explained you how the elements are placed in periodic table, the various periods and various groups, and the lanthanides and actinide series placed below the periodic table. As I told you last time, you please open the periodic table in front of you. It would be a good reference. Now, in brief, I will summarize about the periodic table that we discussed last time. It consists of 7 horizontal rows which are called periods, and as per the new notation, there are 18 groups. First group and second group has 1 electron and 2 electron in the outermost orbit. 3 to 12 groups have 2 electrons in the outermost orbit, but they are only from period 4 to 7, which are called transition elements. Then from group 13 to 17 we have 3, 4, 5, 6, 7 electrons in the outermost orbit. The last one is halogen family. And after that we have got group 0 or group 18, which has noble gases. This is in brief about the periodic table. Now we have to see how does the property change from left to right in a row and from top to bottom in a column. So first I will explain you the various properties. The first is atomic radius. This I suppose you know what is atomic radius, because you know that yesterday I explained to you that in the center we have nucleus, and nucleus carries the mass. Nucleus carries the protons and neutrons, which is mass of an atom, because mass of electron is negligible. So see, this is my nucleus. This is nucleus, and electrons are rotating in various orbits. So the last orbit is called outermost orbit. So from center of this nucleus to this outermost orbit, so this distance is atomic radius. So this is atomic radius. So even if I have 2 orbits as shown in the diagram, but if the charge in the nucleus increases, means positive charge has increased. So if the positive charge has increased, it will attract the electrons with the greater force. So the size will become small. We will discuss this after some time, but this was just a brief introduction of what is atomic radius. Now what is ionization potential? This is very important term. For this term we have to take outer electron in the outermost orbit. This is the outermost orbit, so there is one electron here. This is 1 electron in the outermost orbit. Electrons are negative charge, so electron is rotating in this orbit. Now this is an atom of a gas. This is an atom of a gaseous atom. So this is very important to write in exam, that this is a gaseous atom, and it is isolated. Isolated means this atom and its next neighboring atom in all the directions have no force on it. There is no any type of electrostatic force between this atom and its neighboring atom. So this will say an isolated atom. So in case I am taking a gaseous isolated atom and I am removing this electron, so when I am removing this electron, will this electron come out? Will this electron come out from the orbit? No. The positive charge of the nucleus will attract this electron towards itself. So this electron is getting attracted here. So electron is getting attracted in this direction. So as electron is getting attracted in this direction, I will have to do work in removing the electron from here. So the amount of work that I do or amount of energy that I will spend in removing this electron is called the ionization potential of this gas. Is it alright what is ionization potential? So it is the energy required to remove an electron from outermost shell of isolated gaseous atom. So these words are very important. It should be isolated gaseous atom and electron has to be from outermost shell. Now we'll define next term and further we will discuss after some time on ionization potential. Electron affinity. Affinity means attraction. So because all electrons in various orbits are being attracted by the nucleus. So in case there is some electron which is flowing here, which has come from other atom or from battery, and that electron enters the orbit of this atom. Now this electron is entering the orbit of this atom. So when the electron will come, this nucleus will attract it, so it will not be able to leave it. Now as soon as it is coming, as such, these various electrons in the outermost orbit, they will repel it, because like charges repel. So as such, when the electron comes to this orbit, it releases some energy. It releases some energy. So that is why now the atom has released the energy. So now in case we want this electron should go out from this orbit, we will have to supply the energy. So the amount of energy required to remove an electron from outermost orbit is called ionization potential, and amount of energy released when gaseous atom accepts such electron. So that is electron affinity. So ionization potential means electron we are removing. Electron affinity means attraction. So electron is getting attracted towards the atom, it is coming in the orbit. So at that time it releases certain energy. The next term is electron negativity. Now these two terms appear to be similar. Now what is electron negativity? Electron negativity means whenever we are forming compounds, like suppose we have sodium chloride, we have hydrogen chloride. Now sodium chloride is made up of two atoms, sodium and chlorine. HCl is made up of two atoms, hydrogen and chlorine. Water is made up of three atoms, oxygen and on both the ends hydrogen. HOH we can say. Now they are sharing the electron. One has donated the electron. So like hydrogen and chlorine both have given one electron. That pair is rotating about both. Now whether that pair is in really center of H and Cl or it is towards one end. Okay. See, suppose this is hydrogen, this is chlorine, this is hydrogen, this is chlorine. H has given one atom because these are covalent bond. H has given one atom, chlorine has given one atom. So this is called this pair of atom that is common to both H and Cl. It is rotating around H, it is also rotating about Cl. So is it exactly at the center? No. It depends upon electronegativity of hydrogen and chlorine. Chlorine is more electronegativity. Chlorine has more electronegativity. So the pair would be, this is H, this is Cl. It will not be at the center. The pair may be somewhere here towards the chlorine end. So this is the electron pair at the center, average position. Electron pair is here, not towards hydrogen but towards chlorine. It is towards the atom which has more electron negativity. So this electron negativity, there are various scales, but most widely scale is Linus-Pauling. Most widely scale is Linus-Pauling. So as Linus-Pauling has given this rating of electron negativity of all atoms. Now if you see those rating table, we will see that highest is for fluorine, which is 4, and minimum is for cesium, which is 0.7. I will explain you that why this is highest and why this is lowest. So it is 4 for fluorine, 0.7 for cesium, hydrogen is 2.1, these you should remember, oxygen is 3.5. So oxygen is more. So in case of water, my electron pair is more towards the oxygen as compared to hydrogen. So it is more towards oxygen. So in case, so this becomes like a negative, partly negative charge, and this becomes like a partly positive charge. Similarly, in case of HCl, electron is more towards Cl. So Cl acts like a partly negative charge and hydrogen acts like a partly positive charge. So whenever, so this case will arise only when two atoms are making covalent bond, which I will be explaining in the next chapter, that what is covalent bond, but you might have studied something in the 9th standard. Covalent bond means it is between two non-metals, both are giving electrons and they are sharing that pair. Is it alright? So these are the various important terms. The remaining terms are very simple. You know what are non-metallic. Non-metallic are those elements which gain one or more electrons, like chlorine, bromine. They have got 7 electrons in the outermost orbit, so they will try to gain 1 electron to complete that orbit, means to make that orbit stable, means to have 8 electrons in the outermost orbit. But if we take sodium, it has 11 electrons. Yesterday we have seen its electronic configuration is 281. So it will try to donate this 1 electron. So it will try to lose this 1 electron. So sodium is a metal. So elements, so you should first check the atomic number of the element, then you draw the electronic configuration and see whether it will donate the electron or accept the electron. And in case both are want to accept, then they share, and that is called covalent bond. Is it alright? Then physical properties like density, melting point, boiling point, how do they change? Chemical properties, whether they are reactive, less reactive, what are the types of hydrides they form, what type of their oxides of what nature, alkaline or acidic or neutral. So all those things we will be studying how this chemical properties change. So these are the various properties that we have to study. How do they change along the period, means from left to right, and vertically down, means we say down the group. Okay. So this was, I have introduced you. I hope you have opened this table. Now you see, so whenever I say across the pyramids, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Down the group means beryllium, magnesium, calcium, strontium, barium, radium. This is down the group. Now we have to study for all periods how do they change along the period and how do they change in a vertical column. That is groups. Now you will see here, these are highly positive metals. They are metals, highly reactive metals. So my first group is having highly reactive metals, and my last group 7A, if I 17th group, if I take fluorine, chlorine, bromine, as I told you yesterday, they are called halogens. So they are highly non-metal. Last is 18th group is neutral. Their orbit is complete. So you will see here, beryllium, or you might have been knowing magnesium is less reactive than sodium. So this is highly reactive metal. Magnesium is a bit less reactive. Aluminium is also metal, but it is still less reactive. Then here it is highly non-metal. So my property, how does the property change? Metallic properties are decreasing, or somebody can say non-metallic properties are increasing. So here this is highly non-metal. This is less non-metal compared to fluorine. So this is how we have to see. So first property we have seen that if we move along the period from left to right, my metallic properties will decrease and my non-metallic properties would increase. Now if we go down the group, whether we take this group or this group, we will find that these elements are highly reactive compared to the top ones. Sodium is less reactive compared to potassium. Cesium is highly reactive. Francium is more reactive than cesium also. So my reactivity of metals is increasing as we move down the group. But if we take the case of halogens, fluorine is highly reactive non-metal. Chlorine we have studied is highly reactive non-metal. Bromine is less reactive. Iodine is very less and actinide is much less. So in case of non-metals, my reactivity decreases down the group, but metallic properties increases down the group. Is it all right? So this is how we have to study the all properties that I have explained to you along the period and down the group. So now we'll go to one by one property and try to see how do they change. Now before discussing the various properties, what are the reasons that there is a trend in properties? Because as we had seen last time, electronic configuration changes, but in a group, in the same group, outermost orbit has same number of electrons. So chemical properties are decided by outermost number of electrons in the outermost group and number of cells. But more dominant factor is number of electrons in the outermost group. So that in a groups are same. So when we have listed the property elements in increasing order of atomic number, and then we observed that they are repeating. Number of elements in the outermost groups are coming same. So they came in the same vertical group. So the properties are also repeating in the same manner. But due to extra cell, there is slight gradation of properties. Now in the period, what happens? My one electron is increasing as we move towards the right. So due to change of only one electron, there would be small degradation, small variation in properties. Like as we have seen that in case we take see here, lithium, beryllium. So beryllium is less reactive than lithium because here it has two electrons. This is having only one electron, the outermost orbit. So as we are moving, the properties are gradually changing. This is also behaving like lithium, but to a slightly lesser extent. Boron has got 3. So it has reactivity will further decrease because now it has to donate 3 electrons in the same then further metallic. So that is why metalloids would be in this place between metals and non-metals. That I will also explain to once. Okay. So now let us try to study the variation in properties one by one now. So first we will see atomic size. How does the atomic size change along the period and down the group? Now it is very obvious that if number of cells are increasing, then the size of the atom will increase. 1 orbit, 2 orbit, 3 orbit, 4 orbit, 5 orbit. Definitely the size of 5 atom having 5 orbits is more as compared to 4. So this is very important fact. So as we move down the group, my number of cells will increase by 1, so the size of the atom will increase. The size of the atom depends on number of cells. Second factor is the nuclear charge that the atom has. Now when I am moving in any period, then number of orbits are remaining same, but charge is increasing by 1. So due to more charge, the electrons in the outermost orbit are also attracted more towards the nucleus, so its radius decreases. So as we move along the period from left to right, due to increase in nuclear charge, my size decreases. So this you should learn. So I have given certain values also, that we consider second period. Then for lithium, the size is 1.55 angstrom. Angstrom means 10 raised to minus 10 meter, and it becomes only 0.64 angstrom for fluorine at the 7th. Neon, it having the all orbits complete, a stable atom, so the 8 electrons are outermost orbit, so they repel among one another, and therefore the size has increased to 1.12. So compared to fluorine, always inert gases size increases compared to halogen, which are their neighboring atoms. Otherwise, if we move from left to right, my size decreases due to more nuclear charge. Is it all right? Now if we go down the group, then the size of the atom will increase because of more cells. So the radius will increase, size of the atom will increase. But due to more nuclear charge, electrons will get attracted toward the center, but the size of the atom gets more determined, or the dominating factor is the increase in number of cells. So due to more number of cells, that will dominate and my size will increase, because due to more nuclear charge, size would decrease, but net effect is that the size of the atom increases as we go down. So I have given here also example. Hydrogen is minimum 0.37 and cesium is having maximum 3.62. So you can see the size 0.37 for hydrogen, which is the first atom in the first period, and cesium is 2.62. Same if we take halogen family, group 17, fluorine is 0.64, actinides, which is at the bottom, is 1.4. So the size has increased of 0.64 to 1.4, more than double. So the size dominating factor is the number of cells. Had the charge not would have been there, the size would have been much more. Okay, so now we will continue further. So now we will study ionization potential. I had introduced to what is ionization potential, amount of energy required to remove an electron from outermost shell of isolated gaseous atom, and this will get converted to positive charge now, because one electron has gone, so number of protons will become more than number of electrons by 1, so it will become positive 1 charge. Now energy required to remove first electron is called IP1, ionization potential of 1, or IE1. Now if I remove second electron also from the outermost orbit, then the energy required to remove it would be much more than the earlier one. Why it is much more than earlier one? Because Now I have to remove that electron which I removed in the earlier case. Also now I have to overcome force of repulsion between electrons, because the cation has become positive charge. Cation has, because as I told you that it has become positive charge, the ion has become positive charge. Now I want to remove the electron from positive charge. So positive charge is attracting the electron. Initially, when I was removing first, my ion or my atom was neutral. Now I am removing from a cation which is having positive 1 charge. So this charge I have to now overcome the force of attraction between cation and the electron that I am removing it. So my ionization energy for second would be more than first, and ionization energy for third would be more than second, because now cation will become positive 2. So the force of, I have to overcome large force of attraction between cation and the electron. Is it all right? So now let us know, so what are the factors on which ionization energy depends? So it depends on nuclear size. It depends on nuclear size. More is the nuclear size, there is a less attraction between the electron of the outermost orbit. So I have to overcome less force, so less energy is required. Then it depends on the nuclear charge. If the nuclear charge is more, so that electron is getting attracted with a larger force, so more energy would be required, so ionization energy will be more. So these 2 points you should learn, that if nuclear size or nuclear radius is more, if nuclear radius is more, then the force of attraction between electron of the outermost shell and nucleus would decrease, so less energy required. Is it all right? So the nuclear size and nuclear charge. More is the nuclear charge, radius is same now, nuclear charge is more, so then you will have to supply more energy to remove it. So more the nuclear charge, greater the attraction of the electron, so more ionization energy will be required. So now let us try to see how does ionization energy vary as per in the period. So I have written the period, you can see I have written the period, see here, lithium. So lithium it is 520. So this is the period 2. You can lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, that period 2. You will see that it is increasing, ionization energy is increasing, 520, and this is 2080. This is 1680, 1300, 1400. So it is normally it is increasing as we move from left to right. So it is minimum here. Why it is increasing? As I told you, now all of second period, so size of the atom due to number of cell will not increase, but the size decreases to smaller extent due to more nuclear charge. Nuclear charge is increasing, so size of the atom is decreasing. As size is decreasing, so force of attraction between nucleus and the outermost electron will increase, so I will have to supply more energy. So you can see energy is kilojoule per mole, 520. Now this is an exception. It has come much more compared to 800. It should have been somewhere in between the two. Here also always second and this fifth period show certain anomalies. So this is also much more compared to this. It should have been somewhere between 1000 and 1300. So these two are we calling it exceptions. But so in nutshell we can say that across the period my energy increases. So ionization energy increases from left to right. Now we'll go to next slide. Now in this slide you will see, now we are going down the group. So we are taking group 1. So we are taking group 1 and seeing how does the energy change in group 1. So you can see for hydrogen it is 1300 and for cesium it is only 375. So it has decreased. You can have a look at the table. It is decreasing. If you forget about hydrogen, then it is decreasing to smaller extent, 520, 498, 419, 403, 375. So down the group it decreases. Why it decreases across down the group? Because nuclear charge is increasing. Size is also increasing. But now in this case nuclear charge is also increasing, size is also increasing. So which is predominating? Which is dominating? Increase in size, which is reducing, is dominating. The size, nuclear size is increasing and that is dominating, because if the size is more, then less energy, it will attract with a lesser energy. So in case of cesium, it has got a very big size, so the outermost electron is very far away. If this is the nucleus, in one case it is here and in other case it is here. Now this side is more, so here the attractive force would be less compared to attractive force here. So as we move down the group, my size is increasing, that is dominating, so my ionization energy is getting decreased. So that's what I have shown it here. Ionization energy decreases down the group. This you should learn. Ionization energy increases across a period. Is it alright? So as I have told, shown here, ionization energy increases across the period. Metals are on the left, non-metals are on the right. So ionization energy of metals would be low and non-metals would be high, because non-metals are on the right. Ionization is increasing across the period. Now this is mathematically. Now let us try to see logically why. See, metals have got 1 or 2 electrons in the outermost orbit, and it is not, they are not interested. They want to attain the stable condition, so we can easily remove them. So I is less. Whereas in case of halogens, which is a non-metal, they have got 7. They want 1, so they want 1 more electron. So it is difficult to remove electron from a non-metal. So this is how you can just remember that in which there is. I will tell you another trick for remembering at the end of the lecture. Is it okay? So now we'll go to next parameter, electron affinity. I have explained you what is electron affinity. Electron affinity means amount of energy released when an atom in gaseous state accepts electrons. So when you will take an electron from negative charge, so it will form anion. In ionization, what we have learned, that when an electron is removed, it becomes a cation, positive charge. So here it is reverse. When an electron is accepted by a neutral atom, it becomes an anion, negative charge. So it will release some amount of energy. That amount of energy that is released is its electron affinity. Okay? Now here also, in all parameters, you should think from these 2 points of view: size of an atom and charge of an atom, nuclear charge. That what is happening across the period, what is happening down the group, and which is the dominating factor. Okay, so now we will go first across the period. So if we go across the period, what will happen to the size? Size will decrease, nuclear charge will increase. Size will decrease. So if the size decreases, what will happen to electron affinity? Small size atoms has more electron affinity, because size is small, so they are coming very towards the nucleus, so they have to they are attracted with a larger force, so they have got more electron affinity. So just remember this: small size atoms have more electron affinity. If nuclear charge increases, then also electron affinity will increase. Nuclear charge has increased, so it will attract the electron. So these two terms you should learn, then only you will be able to answer the questions regarding electron affinity. Small size atoms has more electron affinity. Nuclear charge increases, electron affinity increases. Okay. Now knowing this, you will be able to answer see the trend across the period and down the group. So first we will go across the period. So in the period, what happens to the size? Size decreases, charge increases. So what? So lithium, I have given the figures here, has electron affinity of minus 0.61 and fluorine has minus 3.6. Inert gases तो zero होगा, they don't want any electron. So electron affinity has increased from lithium to fluorine. Here energy release was 0.61, now energy release is 3.6. So you see the energy release has increased. Therefore we say electron affinity increases from left to right in a period. Inert gases have zero, because they have stable electronic configuration. Now if we go down the group, then atomic size will dominate. What happens to atomic size? Size increases. So size increases. What I told you to remember, if the size is small, more electron affinity. So when the size increases, electron affinity would decrease. So I have written it here. You can see in this that down a group, electron affinity decreases. Down a group it decreases. You can see lithium is 1 and cesium is 0.7. So it is less. Fluorine is minus 3.6, whereas chlorine, which is just below, is minus 3.8. So this is in a group. Okay. You can think about this for a minute, because this is a very important point, that electron affinity increases across a period because the size of the atoms becomes small, but nuclear charge increases. The net effect of these two is that electron affinity will increase. Means more energy would be released when an electron is absorbed by an atom. In a case of a group, the increase in size dominates the effect of increase in nuclear charge. So as the size is increasing, so electron affinity down the group will decrease. Okay, so we move to next slide. electronegativity. If you remember, I had explained you that electronegativity means that the pair of electrons that is being shared by two electrons, is it at the center or it is towards one of the atoms. It will move towards that atom which is more electronegative. As such, more electronegative, just to remember, I can tell you, you can say which is having, because of study just now, electron affinity. Whosoever there are two atoms, both are attracting that pair. So the atom which is having more electron affinity, so it will move towards that atom. So the group of atoms will move towards that atom which is having more electron affinity, and that we say it is having more electronegativity. Now, to measure electronegativity, there are various scales, but most important scale is Linus Pauling, and we have to just know that which atom is having how much electronegativity. So maximum electronegativity is of fluorine, which is 4, because fluorine is on the second period towards the right, so it is a highly non-metal. If we go down the group, the reactivity decreases. So fluorine is highly non-metal, and so to that we have given electronegativity of 4, and to lithium we have given 1, and minimum would be, now 1 is a metal on the top, but as we go down, metallic properties further increases. So cesium, which is at the bottom, is given 0.7. So lowest is 0.7 for cesium and highest is 4 for fluorine. So if we move from left to right across any period, we are moving from metals to non-metal. Non-metals will have more electronegativity. So electronegativity will increase across the period from left to right. And if we go down the group, as we have seen, lithium is 1, cesium is 0.7. So it will decrease down the group. Electronegativity will decrease down the group for the similar reasons that I explained you for electron affinity. Is it all right? Now, I will tell you a simple method of how to learn these variations in periodic properties that we have studied so far. See, so first property we study atomic size. So this is sort of a summary also, you can say. Atomic size. If we go from left to right, number of cells are remaining same, but the nuclear charge is increasing. So as charge is increasing, the cell radius will decrease. So atomic size decreases. So atomic size decreases from left to right. And if we go down the group, then the number of cells are increasing, orbits are increasing, though the charge is increasing, but predominant factor would be more number of cells, so the down the group it increases. So here you can logically learn. Number of valency electron. If we go from left to right, sodium is having 1, and if we go to extreme right, that will be halogen. So number of electrons, the valency electrons, not total number of electrons. So I have written it in color. Valency electrons will become 7, sodium, magnesium 2. So then it will go on increasing. And if we go to now down the group, then what we have learned? Valency electron remains same. We have learned this, not that valency electron remains same in the group. So down the group it will remain same. So simple. Number of valency electrons are increasing. Group number is increasing from 1 to 18. So across the period, valency electron will increase, and down the group it will remain same. Now metallic character. Left hand side is sodium, lithium. So they are highly reactive metals. Right sides are halogens. So metallic character is decreasing. If we go down the group, metallic character will go on increasing. As I told you, bottommost is has maximum reactivity of a metal. So non-metallic character would be opposite of it. So non-metallic in the beginning is not at all non-metal. Right is highly non-metal. So non-metallic is increasing, and down the group it will decrease. Now comes electron affinity, electron negativity, ionization energy. All these three groups have got same answer. If we go from left to right in a period, then ionization energy increases, electronegativity increases, electron affinity increases. Reasons I had explained you. And down the group it decreases. So simple. So to learn as a group that this full group